Hi children, in our Jawahar Navodaya Vidyalaya selection test, otherwise JNVST, the second section is arithmetic. So in that arithmetic test, what are the topics included? Let us check. See, in arithmetic test, the first one is number and numeric system. Second is 4 fundamental operations on whole number. Third, fractional number and 4 fundamental operations on them. Fourth, factors and multiples including their properties. Fifth, LCM and HCF of numbers. Sixth, decimals and fundamental operations on them. 7. Conversion of fractions into decimals and vice versa. 8. Measurement of length, mass, capacity, time, money, etc. 10. Distance, time and speed. And 10. Approximation of expressions. 11. Simplification of numerical expressions. 12. Percentage and its applications. 13. Profit and loss. 14. Simple interest. 15. Perimeter, area and volume. So dear children, there are 15 sections in the arithmetic test. We have to study all these 15 sections. Questions may come from all these sections. So let us discuss each section separately in the videos.
Hi children, number and numeric system, and this is one of the section given in our prospects of Jawahar Navodaya Vidyalaya selection test, arithmetic test. And in this section, usually the questions are coming from the formation of greatest and smallest numbers with some conditions. Suppose we have to find or write the greatest 5-digit number. You know that the greatest digit is 9. So greatest 5-digit number. Now greatest 5-digit number. Greatest digit is 9. So greatest 5-digit number is 9 is writing 5 times. Now suppose we have to find the smallest 5-digit number. So smallest 5-digit number is the smallest digit is a 0, but we cannot write a 0 in the first position of any number, the smallest number when you are writing. So we have to write the next smallest digit, which is 1. So the smallest, I'm writing the smallest 5-digit number. Smallest 5-digit number will be 1, then writing the remaining position with a 0. So it's 0, 0, 0, 0, 4 zeros. So this is the smallest 5-digit number. So this is the way to write a greatest and smallest digit number with a simple conditions. But there are situations, some digits may be given. For example, we have to write the smallest and the greatest 5-digit number using the digits 6, 9, 0, 2, 1. So we have to write the greatest 5-digit number as well as smallest 5-digit number using the digits 6, 9, 0, 2, 1 without a repetition. So what will be the greatest one? So let us G stands for greatest 5-digit number using these digits. So we have to write the greatest digit first from among the given digits. It is 9 here, 9. Then the next one is 6. Then it is 2, and here 1, 0. So 9, 6, 2, 1, 0 is the greatest 5-digit number using the given digits 6, 9, 0, 2, 1. without repetition. And what about the smallest one? Smallest one, we have to write the smallest digit, but here 0 is the smallest digit. We cannot write 0, so we have to write the next smallest digit among the given numbers, which is 1. 1. Then we can write we have to write the smallest digit 0, which is in the list of numbers. So 1, 0, then the next number is smallest one is 2, then 6, 9. So these are the two numbers, greatest and the smallest, without using repetition. Let us discuss a question usually asking in the Jawahar Navodaya Vidyalaya selection test. What is the difference between greatest 6-digit number and the smallest 4-digit number? So greatest 6-digit number is the digits number formed by the digits 9. 9 6 times. So 9, 9, 9, 9, 9. No, only 5, one more 9, 6. Now, what about the smallest? Smallest, I'm writing smallest, and smallest is the number starting with, actually, it is 4-digit number. So, 1, 0, 0, 0. Now, we have to take the difference. The difference is, and here it is 9, and here also 9, 9, and 9 minus 1 is 8, then 9, 9. So this is the difference between greatest 6-digit number and the smallest 4-digit number. Okay, children? Now, children, the difference between greatest and the smallest 5-digit numbers formed by the digits 0, 3, 6, 7, and 9 without repetition is A, 93951, B 67061, C 66951, D 60840. Now, let us write the greatest one. So, greatest 5-digit number using the digits 0, 3, 6, 7, 9, and it is the greatest, right? 9 number digit is 9. We have to write 9, then 7, and 6, 3, 0. Now, what about the smallest one? Smallest one, we cannot write 0 first, so 3, then 0, then 6, 7, 9. Let us take the difference. So, here it is 1, and here it is 5, and here 9, and here 6, and 6. So 66951. So the correct option is C, 66951. Actually, it is a question asked in the previous year JNVST for class 6. Next, we have to discuss about the odd and even numbers in our number system. Odd numbers are odd numbers. Odd numbers are 1, 3, 5, 7, 9, etc. And what about the even numbers? Even numbers are 0, then 2. Even numbers are 0, 2, 4, 6, 8, etc. Generally, people will write 2, 4, 6, 8, etc. But 0 is also considered as an even number. So, even numbers are 0, 2, 4, 6, 8, etc. So, odd numbers and even numbers, the questions are based on odd numbers and even numbers also may be there. Here, upon question, the sum of digits of a number is subtracted from the number. The resulting number is always divisible by 9. It's a result actually. Let us consider one 2-digit number. Let it be 83. Now, sum of the digits 8 plus 3 is equal to 11. Let us take the difference from 83. So 83 minus 11, and here are 2 and 7. 72 is divisible by 9. How to check the divisibility by 9? You just add 7 and 2. You will get 7 plus 2, which is 9, divisible by 9. Now, if you take another example as a 29. Now, what about the sum of the digits? 2 plus 9. Again, it is 11. So, 29 minus 11, and that is 18. 18 is divisible by 9. Children, the next section is 4 fundamental operations on whole numbers. The operations are, we know that it is addition, multiplication, subtraction, division. But doing mathematical simplification, we have to follow some order of the operations, and that is the famous board mass. What board mass stands for? Board mass stands for bracket of division, multiplication, addition, and subtraction. So we have to do the operations inside the bracket first, then division, if any, then multiplication, then addition, and subtraction. Let us do one example. I'm writing in a simple example here. It is 23 plus 6 into 12 divided by 3 minus 4. So, but inside the bracket, this is 12 divided by 3. So, we have to do the bracket operation first of all. So, it is 23 plus 6 into 12 divided by 3, and that is 4 minus 4. You are not supposed to subtract 4 minus 4. So, next is the operation we have completed, bracket and division over. Now, there is no division or bracket here, but the multiplication is there. So, you have to do the multiplication first of all. So, it is 23 plus 6 fours are 24 minus 4. Now, we have to, the multiplication is over. Now, we have to do the addition. So, it is 23 plus 24 is 47 minus 4. Now, we have to do the subtraction. So, 47 minus 4 is 43. So, the correct answer is 43. So, this is the example of using board mass. And we have to use the board mass not only in whole numbers, in the fractions also. Now, next, we have to discuss about the predecessor and successor. Predecessor and successor. Suppose take a whole number, 25. 25 is a whole number. The predecessor of 25 is just 1 less than 25. So, predecessor of 25 is equal to 24. Now, what about successor of 25? Just add 1 to 25, and that is 26. So, predecessor is 25 is 25 minus 1. Successor of 25 is 25 plus 1. But, dear children, for the whole number 0, for 0 has no predecessor in whole number. 0 has no predecessor in whole numbers. But we are discussing integers. 0 has a predecessor, and which is negative 1. 0 predecessor, in the case of integers, the predecessor is a negative 1. But when we are discussing whole number, there is no predecessor.
The children, let us discuss some tests for divisibility of numbers. Divisibility by 10. If a number has 0 in the ones place, then it is divisible by 10. That is, if a number is ending with 0, then it is divisible by 10. Divisibility by 5. A number which has either 0 or 5 in its ones place, then it is divisible by 5. So, if a number is ending with 0 or 5, then it is divisible by 5. Divisibility by 2. A number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its ones place. That is, if a number is ending with 0, 2, 4, 6 or 8, it is divisible by 2. Divisibility by 3, and it is interesting. if the sum of the digits of a number is a multiple of 3, then the number is divisible by 3. For example, let us have a number. I am writing 1, 3, 3, 4. Let us check. What about the sum of the digits? 1 plus 3 plus 3 plus 4, and that is equal to 1 plus 3 is 4, 4 plus 3 is 7, plus 4 is 11, which is not divisible or by 3 or multiple of 3. Therefore, this given number 1334 is not divisible by 3. Let us have another example. 512. Now, what about the sum of the digits? 5 plus 1 plus 2, and that is equal to 5 plus 1 is 6, 6 plus 2 is 8, 8 is not multiple of 3. So, the given number, this number is also not a multiple of 3. Now, let us take another number. 3, 1. So, the number is 3144. Let us check the sum of the digits. So, 3 plus 1 plus 4 plus 4, and that is equal to 3 plus 1 is 4, 4 plus 4 is 8, 8 plus 4 is 12, 12. 12 is a multiple of 3. So, the given number 3144 is divisible by 3. So, this is divisible by 3. Now, this is the procedure of checking the divisibility by 3. Let us check next, divisibility by 6. If a number is divisible by 2 and 3 both, then it is divisible by 6 also. So, if a number is divisible by both 2 and 3, we know the checking of divisibility by 2 and divisibility by 3, we have to check both. If both the number is divisible by 2 as well as divisible by 3, then the given number is also divisible by 6. That is let us have an example. So, 24, I am writing 24. Now, what about the last digit? Last digit is 4, so it is divisible by 2. Now, what about the sum of the digits? Sum of the digits is 2 plus 4, and that is equal to 6. 6 is a multiple of 3, so it is 24 is divisible by 3 also. So, 24 is divisible by 3 as well as divisible by 2. So, the given number is divisible by 6. Now, divisibility by 4. A number with 3 or more digits is divisible by 4 if the number formed by its last 2 digits, that is ones and tens, unit place and tens place, is divisible by 4. So, that is we have to check the last 2 digits is divisible by 4 or not. For example, I am writing a number is 5212. Let it be 5212. What about the last 2 digits is 12. Now, check whether 12 is divisible by 4. Of course, 12 is a multiple of 4. So, the given number 5212 is divisible by 4. Next is divisibility by 9. If the sum of the digits of a number is divisible by 9, then the number itself is divisible by 9. So, this is just like the divisibility test of 3. Now, let's have an example. So, I am writing the example as 729. What about the sum of the digits? 7 plus 2 plus 9, and that is equal to 7 plus 2 is 9, 9 plus 9 is 18. So, 18 is a multiple of 9, otherwise divisible by 9. So, 729 is divisible by 9. Let us have another example, that is 1331. What about the sum of the digits? 1 plus 3 plus 3 plus 1. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 1 is 8. 8 is not divisible by 9. So, the given number 1331 is not divisible by 9. Now, divisibility by 11. Find the difference between the sum of the digits at odd places from right and the sum of the digits at even places from the right side of the given number. If the number is either 0 or divisible by 11, then the number is divisible by 11. Let us have some example with it. Here in the table, the number is, first number is 308. What are the sum of the digits at odd places from right side? The digits at odd places from right side are 8, this number 8 and 3. So 8 plus 3 is 11. Now digits, otherwise sum of the digits at even places from right side. There is only one digit at the even place, so that is 0. Now the difference between 11 and 0 is 11, which is multiple of 11, otherwise divisible by 11. So 308 is divisible by 11. Now next number is 1331, 1331. The digits at odd places from right side are 1 and 3, and their sum is 4. And digits at even places are 3 and 1. Sum of the digits at the even places from right side is again 4. Now 4 minus 4 is 0. 0 is, if the difference is either 0 or divisible by 11. So 0 is possible. So when it is difference is 0, then it is divisible by 11. Another example, 61809. So the digits at odd places are 9, 8, 6. So 9 plus 8 plus 6 is 23. Now even places at 0 and 1. So difference is 23 minus 1 is 22. So it is divisible by 11. Let me take another example. 7, 2, 1, 3, 4. So what are the digits at odd places? 4, 1, 7. We have to take the sum first of all. 4 plus 1 plus 7. 4 plus 1 plus 4 plus 1 is 5. 5 plus 7 is 12. So it is 12. Now digits at even places 3 and 2. So 3 plus 2, and that is equal to 5. Now their difference is 12 minus 5, and that is equal to 7. 7 is not divisible by 11. So the given number 72134 is not divisible by 11. So this is the procedure of divisibility by 11. Dear children, what we have discussed right now, the divisibility test for 10, 5, 2, 3, 4, 6, 9 and 11. All these divisibility tests are important, and it will be very much helpful for you for appearing our Jawahar Navodaya Vidyalaya selection test. Thank you.